Our today's class is about network analysis, or what we call network modeling. This is the fourth unit in your operation research course, and therefore we want to learn something about how to draw a network scheduling. And now the first method that we want to learn is about PERT, Project Evaluation Review Technique. Now, project evaluation review technique is a kind of tool that we use in doing our drawing a network model for the project manager, and it uses what we call probabilistic estimate. It gives 3 time estimate. It's not accurate. Because it is not accurate, therefore, it uses what we call 3 time estimate. It is very important because for cases whereby we find that there is uncertainty is great, project that runs for a slightly longer period of time, estimating a cost that comes for perhaps 10 years from today becomes sometimes challenging, and therefore it is better that we give our variety of range, and that type that gives that variety of range is what we call as the PERT method of drawing the network. So now the PERT is also used mainly for what we call research and development and project, and I've already said that the PERT considers into consideration planning methodology where uncertainty is great. And PERT also, we can use both what we call the activity on arrow and activity on node model in presenting the PERT, just like the critical path methodology. So we want to use now an example to give an illustration of how you are supposed now to use PERT to do what you call your network model. So now the examples that we presented here is various activities of a project, and now this project has 1, 2, 3, 4, 5, 6, 7 activities. It has 7 activities, and then you have been presented here about the relationship between project, which is called the predecessor. Now this point estimate is what we call the optimistic time estimate. OP is optimistic time. Now this is time estimate taking into consideration that everything may go well. If everything goes well, then we present that activity A will take 12 days. Okay, and then we also have what we call most likely time estimate, and this is what we call the probable estimate. This is the probable estimate, and then pessimistic estimate is taking, or this pessimistic estimate is the longest time estimate, taking into consideration that everything may not go well. So this is the longest usually. We are assuming that things may not go well, so we present what we call pessimistic estimate. So the relationship between, like, once we can begin, when we begin this project, we can start with activity A. This is the first activity, and it does not have what we call a predecessor, which means now this is the beginning of the activity. From what you call the groundbreaking of the project, you can just begin with this activity. Activity B can only begin after A is complete. That's according to this relationship. Activity C can only begin also after A is complete. It means, therefore, that both activity B and C can run in parallel. You learn something similar about what you call parallel lines. So here we also have the activities that can run in parallel, and activities that can run what you call sequentially, which means one must be complete is when we begin another. Like, for instance, completing activity A will give us an avenue for us to start either activity B and C. If we look at activity D, can only begin after C is complete. It means once we have already through with what you call activity A, we can begin C straightforward. So activity C now follows after A is complete. Activity E can begin after B and D is complete. If you consider activity B and D, the activity B and D needs complete so that we can begin activity E. So that is a condition that is in the relation. Activity F can begin after activity E is complete, and activity G can begin after activity F is complete. And most likely, perhaps this activity G is the last activity for me to have this project. Various time estimate in terms of days have been presented various time estimate has been presented as shown in the diagram below. And then the first question that we are expected to answer is draw the network diagram. We are supposed to present what we call this network diagram, or what we call draw the network model. So we need straightforward to know what are some of the things that we require before we draw the network diagram. Now, for us to draw the network diagram, we require all these activities and their sequence, how they are interrelated. But because every activity will be expected to insert the time interval, or perhaps activity A is supposed to take how long, therefore we are expected to calculate the time for each activity. And this time for each activity is called mean time. So we need to introduce a column here where we are calling it mean time. So this mean time is the average time between this, because we have 3 times estimate, so we need to use 1 time. It's called expected time. This expected time is got by this formula that you need to add optimistic time plus 4 pessimistic time plus 4 most likely time plus pessimistic time over 6. So this is the formula that we need to use now to generate all this time estimate for each and every activity. So for instance, it means activity A is going to be 12 plus 4 times 16 plus 26 divided by 6. So that is the duration for activity A. So that duration is going to be, this is 4 times 16 is, we have 64, plus 12 we have 76, plus 26 we have, here is 2, 102. So this 102, if you divide by 6, you get 40, 42. This becomes 7. So this is 40. This is 1. This is 1, 42. It goes here 17. So it means activity A, the duration that will be represented is 17 days. We go to activity B. This is activity A. Activity B, using that formula, activity B is equal to 6 plus 4 times 9 is 54 plus 18 divided by 6. So we also add this. This is like 18 plus 6 is 20. 24. 24 plus 54, we get 78 divided by 6. This is 1. 18 goes here 13 times. So activity B is 13. Now we go to activity C. Activity C is supposed to be 8 plus 10 times 4 is 40 plus 18 divided by 6. So this gives me 8 plus 40 plus 18, that I will have 48. 48 plus 18, I will get, this is 6, I will get 5, this is also 6. So this is like 66. 66 divided by 6 is 11. So it means activity at C is supposed to be 11. So this becomes 11. Then I go to activity D. Activity D is 2. Activity D is equal to 2 plus the most likely times 4. 3 times 4 is 12 plus pessimistic time is 4 divided by 6. So this is 2 plus 12 is 14 plus 4 is 18 divided by 6 is 3. So this becomes 3. Now activity E. Now activity E is equal to 3. Activity E is equal to 3 plus 8 times 4 is 32 plus 16 divided by 6. So this becomes 3 plus 32 is 35. So this is like 35. 35 plus 16, I will have here 1. I will have there 51. So I will have here 1, here 4, 5, 51. So this is like 51 divided by 6. So if I'm not wrong, this is 3 plus, no, it is not 8. This is 4. 4 times 2 is 12. This is 12. And then the last one is 11. The last one is 11. So that calculation was not correct. So the optimistic time is 3 plus 4 times 4. 4 times 4 is 16. And then this is 11. So if you add this divided by 6, so I will get 19 plus 11. That is 30. So 30 divided by 6, I get activity E is 5. So this becomes 5. Then the activity F is 6. F is equal to 6 plus 8 times 3 is 32 plus 16 divided by 6. So this becomes 38 plus 16. This is 4, 54. 54 divided by 6 is 9. So this becomes 9. And then finally, the final activity F, G is equal to 15 plus 20 times 4 is 80 plus 25. So if you add this 15 plus 25, we get 40. So this gives me 120 divided by 6 is 20. So it means now the mean time for various these activities have been provided. as shown in the diagram. Therefore, we can straightforward go to drawing what you call the network. We can draw the network. So when drawing the network, we need to consider the relationship between activities, and then we'll insert also what you call the time, so that we can be able to calculate the critical path. So now we to draw the network, I will use what you call activity on arrow method of drawing the network. Therefore, I begin off at 0 at that point. Then I put this activity A, this activity A. So once I'm through with activity A, I can begin activity B and C. So it means activity B can begin and activity C can also begin. This is activity B, this is also activity C. So I can begin that way. So I've already presented activity A, B, and C. So activity D can begin after C is complete. So after C is complete, I can begin with D. Remember, this is sketch. Usually it is better you begin with a sketch, then you can write the final one, because I subject to change. So, and remember, the activities must be presented on arrow basis according to AOR method, AOA method, okay? So now I need to continue from D, I put E. So activity E can only begin after B and D is complete. So let's look at B and where D is. There is B and D. So these activities needs to complete before we can do what? Because we can begin. It means we must join. This is parallel, this is parallel. And therefore, it is better when I extend this activity down here, and then this E, I bring it like this. I join it up here, so that this becomes, they join together. So B and D. So D can join now there. This goes up there. So once it is joined there is when we can generate another activity which is called E down there. So E, this is activity E, okay? A situation whereby I look at what I've already done, I've joined this one just straightforward like that. But in case I'm not able to join them, then that is where you use what you call a dummy. In case there is no way you can join them. So I've already done this, so I go to F. F begins after E is done. So I can generate F. And after F, I can generate what you call G also. I can generate G also. So this is the final activity. And then this is how my network looks like. So I only need to put the various signs indicating that it is an activity on arrow basis of drawing the network. So that is what I have so far. So what I need to do is I need to calculate what you call now the critical path. How long is it supposed to take? So that is very important. So in order to calculate the critical path, I'm supposed to can use two methods. I can either use what you call forward pass, and then I do what you call backward pass. And now, if I do this, I find what you call the floats between what you call activities. The one that has 0 floats all throughout, that means it's a critical path. Alternatively, it's just inserting all the duration and assessing the longest path. That is the most common definition. The longest path is actually the critical path. So let's look at inserting the duration. Remember, it is the mean time that we need to insert. Activity A was supposed to take 17 days. Activity B is supposed to take 13 days. Activity C is supposed to take, B is 13. C is supposed to be 11. D is supposed to be 3. D is 3. E is 5. E is 5. Next is F is 9. This is 9. And then finally activity G is 20 days. So I've already inserted that. So it means you can do what you call determining the critical path. How long will it take to complete this project? Which is the longest path? That's like that question. So I can take two paths. I can move from A, B, E, F, G. Or alternatively, I move to A, I come to C, I go to D, I go to E, I go to F, I go to G. So there are only two paths in this that I can be able to move. So I take now A, I move to B, I move to E, I move to F, I move to G. So how long is that? This is A. A takes 17, this is 17. B is 13. E is 5. F is 9. And then G is 20. So how long is that? So this is like 17 plus 13 plus 5 plus 9 plus 20. So this becomes 17 plus 13 is 30. 30 plus 5 is 35. So 35 plus 9 is 44. 44 plus 20, this is 35 plus 9 is 35 plus 9 is 44. 44 plus 20 is 64. So that part will give me 64 days. So I need to come to the lower part again. So it's A. After A, I go to C. Then I go to D. I go to E. I go to F. I go to G. So A is given to be 3. E is given to be 5. F is given to be 9. G is given to be 20. So I also need to add these ones up here. So 17 plus 11 is 28. 28 plus 3 plus 5 is 8 plus 29. So this will give me, this is 36 plus 29. This gives me 65. This gives me 65. So this is 65 days. So now if you compare the two parts, the one that provides me with the longest path is the lower one. So it means it is my critical path. Therefore, I need to put it with the denotation of critical path, just like what I've already presented. So I say now critical path will be A, C, D, E, F, G, which is 65 days. And now that is the duration that the project will be able to take. Now after that, we have already identified the longest path. So it is 65. So you need to go and answer the final question that asks finding the probability. The second is finding the probability that you can be able to do this project in 70 days. Now, finding the probability requires you to be able to calculate what you call the variance of all the critical activities. So we come here and then introduce a column under mean. We shall introduce a certain column here called variance. And the variance has a formula that you use to calculate the variance. It is actually the pessimistic time, PT, minus optimistic time, OP, divided by 6, and then everything you square. So that is what will give us the variance. The difference between pessimistic time and optimistic time, divided by 6, square everything. So in that case, you will be able to calculate the variance for each and every activity. So let's begin off, calculate the variance for what you call activity, the variance for activity A. The variance for activity A is supposed to be 17 minus 16, 12 over 6. Then you square this. So this is like 5. 17 minus 12 is 5. So this is like 5 divided by 6 square. So you need to get 5 divided by 6. Then you multiply times 2 by itself. You square it. So when you square that, you get 5 divided by 6 is 0.833 times 0.83333 again. You get 0.694. So this gives me something like 0.69. So let me leave it like that. So I go to the second one, the variance for this. But I need to know whether the second one is critical. So the critical is C. So I need to circle these critical activities is C, A, C, D, E, F, G. It's only B which is an uncritical activity in my network. Therefore, I will not calculate what you call variance of an uncritical activity. I only need to consider the ones that are critical. So I come back here and then I get 11 minus, so not 11, but it's 18. 18 pessimistic time minus 8, which is optimistic, divided by 6 square. So this is like 18 minus this is 10 divided by 6 square. So if you square that, what are we going to get? It's 10 divided by 6 times 1.6666. So I will get 2.77. So this is 2.77. Okay. So I go to D. D is optimistic is 4 minus pessimistic is 4 and optimistic is 2 divided by 6 square. So what will I get there? So this is like 2 divided by 6. So it is 2 divided by 6. 2 divided by 6. 2 divided by 6. I get 0.333. So the 0.333, you square it times 0.33333. I get 0.111. That activity is that. So I need now to move to the next one. And the next one is this. The pessimistic one is 16. Optimistic is 6. divided by 6 square. So this becomes like 10. So 10 divided by 6. So it's the same like up here. So the answer will be 2.77 because this is 10 divided by 6. Here it was 10 divided by 6. So that one is already done. So we move now next to the next one. The next one is the final activity, which is 25. 25 divided by 15 divided by 6. So this is 25 divided by this. It's also 10 divided by 6, which is the same. The answer is supposed to be the same, 77. Okay? What we have arrived at as all the variance of critical activities we have calculated. So total variance, we need to get now the total variance of all these we add. So the total variance for this is going to be 0.6, we say 0.69 plus 2.77 plus 0.111 plus 2.77 plus 2.77. So these are the activities that we are supposed to, how many activities are we supposed to have? 1, 2, 3, 4, 5, 6. So are they 6? 1, 2, 3, 4. Calculated, we need to identify. So the first one we have calculated, this is 26. The first one we have not calculated, or the first one we calculated wrongly because the pessimistic time is 26. So this is where we messed up. This is where we messed up. In the first one, we took one which is not correct. So that's why we are having one shortfall. So pessimistic time was 26 minus optimistic time is 12 over 6 divided by 2 square. So this is like 16. This is like 14 divided by 6. So this is 7. This is 3. So this is 7 divided by 3. I get 2.33. I get 5. The first one is 5.44. Okay. The second one is 18. Second one I skip because this is non-critical. It's the only non-critical one. So I skip it. I go to the third one. The third one is 18 minus 8 divided by 6. So this one becomes like 10 divided by 6. So 10 divided by 6. 10 divided by 6 times 1.6666. So it is 2.77, okay, or 2.78. I think that is okay. Then now we go to the fourth one. The fourth one is 4 minus 2 divided by 6 square. So this is like 2 over 2 divided by 6. 2 divided by 6 is 0.333. Multiplied times 0.3333. We will get 0.111. Okay. So that one is already done. We have already done this one. So we go to E, which is 11 minus 3 over 6 square. 11, this gives me 11 minus 3, I get 8. So this is 8 over 6. So 8 divided by 6 is 1.33. Multiple times 1.33. When we square that, we get 1.78. Okay? Then I can present the final one, the second last, which is 16 minus 6 over 6. So this is like also 10 over 6, which is the same like what we already got here, which is 2.78. Then finally, we have here, pessimistic term is 25 minus 15 divided by 6. So this becomes 10 over 6, also 2.78. So this is what we need to get the sum of all elements. So they are 1, 2, 3, 4, 5, 6. Yeah, they're supposed to be 6, like all this. So we'll get now 5.44 plus 2.78 plus 0.111 plus 1.78 plus 2.78 plus 2.78, we get 15.67. So the variance, total variance for all the critical activities is given to be, so our variance is given to be, but we are not interested in the variance. We are supposed to get the square of the variance is supposed to be standard deviation. So the square root of the variance is standard deviation, which is 3.95 or 96. So this is what we require, because you know that when we have been given what you call the probability, we are supposed to calculate P is equal to X minus mu over what we call standard deviation. Now the X value is already been given, which is what we call our 70 value. The X is provided here. So the probability is given now to be 70 minus U, and this mu is what we call the critical path. We've got it to be 65 days, okay, over standard deviation, which we have already calculated here to be 3.96. So if you get this probability, you get that this is 5 divided by 3.96. So the solution for this will be 5. You get 5 divided by 3.96. So it becomes 1.263. Now, if you get this, now you go to what we call our Z table. You go to our Z table, and then you read the directly equivalent for this value, or 1.2. If you go to the Z table, you are going to read a figure that is going to appear there is 0.8962. So this figure is going to be 0.8962. That simply means this is the probability. This is the final from the Z table, normal distribution table. So you get that then the probability for completing that project in 70 days is 89.62%. So that's now the final answer of that problem.